Okay, we're going to learn the washer method today. And so to do this, I'm going to start with an example. We're going to find the volume of solid generating by revolving the region bounded by the curves f of x equals 1 over 10 x squared plus 1 and g of x equals x. So let's start by graphing g of x. So g of x is equal to x. So that's a line straight through the first and third quadrant. And then we're going to graph the curve 1/10 x squared plus 1. So x squared plus 1 and the 1/10 just makes it. So our curve should look something like this. So our region in between these two graphs is this shaded region in yellow here. And we're going to take this and we're going to revolve it around the x-axis. So the first thing we need to do is we need to figure out these intersection points, where the two lines intersect. Remember, to figure out where the two lines intersect, you set the two equations equal to each other and solve for x. So since this is a quadratic, I need to get it equal to 0. And then this does not factor, so I'm just going to use the quadratic formula, identifying my a, b, and c. Remember, quadratic formula is opposite of b plus or minus the square root of b squared minus 4 times our a times our c divided by 2a. Now the cube root of 1/5 does not break down easily, so I'm going to use my calculator and just punch in 1 minus the cube root of 1/5 divided by 1/5 to get 1.13 and 8.87. So those are, I start integrating at 1.13 and then I stop at 8.87. Now we're going to rotate this around the x-axis. Okay, on the left-hand graph, I have the 2D graph of our equation that we graphed on our paper. So we have our linear equation, y equals x in the blue. And in the green, we have the curve 0.1 x squared plus 1, or 1 over 10 x squared plus 1. Okay, so what we need to do is, let me show you on the right-hand side. So let's look right here. This is our 2D dimension of this. And what our goal is here, we're going to find a representative rectangle. And we're going to do it right at x equals 5 here. And then we're going to rotate this around the x-axis. When we rotate it around the x-axis, we form this shape. If you're looking at this, you see that it forms like a circle. So we have this kind of circle shape. It's called a washer because we have an outer circle and an inner circle. And we want to find the area of that shaded region. Because remember when we did volume of the disk method, all the volumes that we find the area of one cross-section. In this case, it's this cross-section because if I go ahead and do the entire surface, this is what our 3D object looks like. So it's this cone kind of shape, megaphone kind of looking shape. And that's what we're trying to find the area of, trying to figure out the area of this 3D object here. And so to do the area of a 3D object, we first have to find the area of this one cross-section. And then we'll integrate from our beginning of our shaded region to our end of our shaded region and integrating all those sums of all those areas of each of the cross-sections. So our goal first is to figure out the area of this brown cross-section. And it's a washer, so this is called the washer method. And notice that we have an outer radius and an inner radius. To find it, we'll find the area of the entire big circle, that's the outer radius. And notice that the radius always starts at our line in which we're rotating around. That's going to become important in a moment. Your radius begins at the axis that you're rotating around when you're using the washer method. So our outer radius starts at that, or at the x-axis all the way up to the blue line. And so that would be that. And notice it would be a circle. And remember, we know the area of a circle is pi r squared. So in this case, it's going to be pi, and r, our radius, is x because it's going to that line, g of x equals x. So it's going to be pi x squared is the area of that big circle. Then we're going to subtract the white circle, the inner radius circle. And notice the inner radius starts at the x-axis and goes to the equation 0.1 x squared plus 1. So the equation of that inner circle, that white circle, it's going to be pi times, in parentheses, 0.1 x squared plus 1, close parentheses, squared. Okay, it's pi r squared, area of a circle. We take the first circle, the outer circle, minus the inner circle, and that gives us our area. So let's do that work over here on our paper. Okay, so from we learned from the graph, our 3D graph and our 2D graph, we need to figure out our outer radius and our inner radius. That's always going to be our first step on the washer method. So our outer radius is the distance to the very height, the upper graph, which is x. Our inner radius is distance to the lower graph in this case. Remember, radius starts at the axis of rotation up to the graph, so here in the green. And so that distance is just my equation, 1/10 x squared plus 1. Now remember, our formula is integral from the area of the outer circle, so pi r squared, and then minus our inner circle, which was pi r squared, but the problem had pi, so I'm going to factor out pi. So our formula is going to become pi, the integral from a to b of the outer radius squared minus the inner radius squared. Know that formula. Anytime you want to do Washer method, that's our main formula. Pi, integral from a to b, outer radius squared minus inner radius squared. So let's substitute in our outer radius with x. In our inner radius, we're going to replace with that 1/10 x squared plus 1. Now we're going to do some algebra before we integrate, because you want to simplify your integrals as much as possible before you integrate. So I'll start by using my full method, taking 1/10 x squared plus 1 times in by 1/10 x squared plus 1 to give me 1 over 100 x to the 4th plus 1/5 x squared plus 1. Now I have some common terms I want to combine. So first thing I'm going to do before I do that, let's distribute the negative, because a lot of people will forget to distribute the negative sign. And then we'll put like terms together, so I'll rewrite this as negative 1 over 100 x to the 4th minus, I'm going to take x squared minus 1/5 x squared, I get 4/5 x squared minus 1. All right, now we're ready to integrate. So the integral of x to the 4th is 1/5 x fifth, and the integral of x squared is 1/3 x cubed, and the integral of 1 is x. Okay, let's simplify that down again to just simply write negative 1 over 500 x to the 5th plus 4 over 15 x cubed minus x. And then I'm going to use my calculator. I'm not going to write this down. I'm not going to require you to write this down. You have all this set up here. So now I'm just going to go to my calculator and replace every x with 8.87 minus replacing every x with 1.13. And then don't forget to times that by the pi. So let's see. If I multiply the upper bound minus the lower bound, I get 68.16. Timesing that by pi, we get 214.14. So the area of this volume of the shaded region is 214.14. Therefore, we know the volume of the solid of revolution that is formed is 214.14 cubic units. Okay, so this is what we left with. Now let's move back. Let's say we're looking at this 3D object now, but instead of integrating on the line y equals x, let's move our integration down here to the line y equals 2, negative 2. Get it exactly on there. There you go. So we're going to rotate around the line y equals negative 2. So as always with the Washer method, your step is to find the outer radius and then the length of the inner radius. So notice that when I rotate it this time, negative 2. And then I'm going to rotate this around. Notice that this is now my circle. Notice this shape, and then if I do the 3D object, the shape, the cone has a little shaped. The shape of the cone has changed a little bit. We're looking at this. So I need to figure out the radius of my outer circle. Well, if I just do my equation, the blue equation, if I just do the blue equation, which is to the x, it only gives me this section. But my radius, remember, you have to start on the line you're rotating. So the beginning of the radius needs to start at that negative 2 and then go up to the blue line. So not only did I travel the height of the blue line, but I actually added 2 to my height. Since I started at negative 2 to get up to 0, I added 2. So my outer radius is going to be x plus 2. Then I need to figure out my inner radius. My inner radius is going to start at the line of the axis of rotation, which is at y equals -2. And then I'm going to go to the green line, this area here. To find the length of that radius is going to be the height of the line, which is height of the curve. Find the area of that radius. To find the length of that radius, it's going to be from the x-axis to the green curve is going to be 0.1 x squared plus 1, and then I need to add in the distance to the axis of rotation. So I made a plus 2. So it's going to be 0.1 x squared plus 3. And that, now I'll set up my integral and solve. Okay, for our second example today, we're going to look at rotating this around the line y equals -2. And remember, we're going to use our formula for a washer, so that's pi times the integral from a to b of the outer radius squared minus the inner radius squared. And so what we need to do is we need to figure out what our outer radius is and what our inner radius is. Remember, radius is always formed by going from the axis of revolution to the outer curve and the axis of revolution to the inner curve to get your outer and inner radius. So let's move to the graph and see what this looks like. Okay, so we got pi times the integral from 1.13 to 8.87 because I didn't change my upper and lower bounds. And remember, our outer radius, the outer radius is taking from the axis of revolution to our upper bound, so that's going to be x plus 2 as we found in our video. And then our inner radius is going to be our 1/10 x squared plus 1. Then we got to add the 2 for that extra distance. And so our outer radius is x plus 2, and our inner radius is 1/10 x squared plus 3. So then we're going to solve this integral just like we did before. So we're going to start by doing the full method and multiplying x plus 2 times x plus 2. And when I do that, I end up with x squared plus 4x plus 4 minus, and then we're going to figure out the full method of 1/10 x squared plus 3 times 1/10 x squared plus 3, which is 100 x squared, plus 6/10, which is 3/5 x squared, plus 9, 3 times 3 is 9. Next, I'm going to distribute my negative and combine my like terms, which gives me a negative 1 over 100 x to the 4th. And then combining my x squared terms, that gives me a positive 2/5 x squared. There's only one x term, so plus 4x. And then combining 4 minus 9 gives me a minus 5. Now we're ready to integrate. Don't forget your pi. So I'll bring the pi down, and we're going to take the integral of this expression. So that's going to give me negative 500 x to the 5th plus 2 over 15 x cubed plus 2x squared minus 5x. And we're going to evaluate this from 1.13 to 8.87. All right, so I'm going to take pi times, plugging in 8.87 in place of every x. I end up with 96.2407 in my calculator. Again, you can use your calculator to help you out. And then when I subtract, plugging in 1.13 in place of every x, I get a negative 2.907. Combining the, subtracting those two terms, I end up with pi times 99.148. And then multiplying by pi, your final answer for the volume of this angle, this shape, is 331.48. And that's how we do the washer method. So I hope this video helped you understand finding the washer method. Again, the main thing, takeaway from this video, is that the washer method, you take pi times the integral from a to b of the outer radius squared minus your inner radius squared. Do not forget that formula. Or another way you can think about, if you don't want to think about factoring out the pi, you can remember that we found this physically by taking the area of the outer circle, so pi r squared, and our r is our outer radius, minus the area of the inner circle, which is pi r squared. but then we just factor out the pi. So that's basically just using the area formula. So whichever way makes more sense for you to memorize.